Hello everyone. Today we're looking at Ethernaut Level 12, which is privacy. In this challenge, we're told that the creator of this contract was careful enough to protect the sensitive areas of its storage. Unlock the contract to beat the level. So we scroll down, let's take a look at this contract. It has a bunch of state variables, a constructor, and an unlock function that we probably need to call. So the state variables will see, the Boolean, uint256, a couple of uint8s, uint16, and a 3-element bytes32 array with a private data. And in the unlock function, it takes in a byte16 value called key, and it requires that key is equal to the byte16 value of data 2, which is the third element in this array. Right, so index number 2, the third element in this array. And if we can give it the correct key, then it sets locked equals false, so it unlocks the contract for us. Now, in previous videos, we've talked about how Ethereum likes to store data, all about storage slots. However, this is a more sort of complicated example with a bunch of different data types, and we need to extract a value from inside the data array. So let's take a look at how storage slots work over here. So we'll head on over to Excalidraw to give you a better visual understanding. So we have this contract, right? And we have a bunch of these state variables. Let me just copy all of these and put them right here. All right. So what happens is, let's take a look at how many bytes these take. I told you each storage slot in Solidity can store up to 256 bits, right? 32 bytes, in other words. So depending on how much space each of these variables is using, they may or may not fit into a single storage slot, right? So for example, the first variable over here, a Boolean, like a Boolean requires less than a full storage slot because it just needs to say, 0 or 1. It doesn't need all 256 bits. So this is definitely going in slot number 0, also because it's the first value, right? When we head on over to the second variable now, this is a uint256, so it requires a full slot, which means you can't shove it in there along with the Boolean. It will need its own storage slot to have all of the information that it needs. So this will head on over to slot 1 in this case. Now, these three variables, uint8, uint8, and uint16, these three, when we add them all together, they are equivalent to, uint32. They take up 32 bits of storage. And 32 bits of storage can all fit together in a single slot. So all three of these values go together into a single slot, which is going to be slot number 2, right? So all three of these get compressed into a single slot because they have enough space to do that. They all head on over into slot number 2. But arrays work a little bit differently. When we start talking about arrays always start at their own storage slots, or anything with dynamic memory always starts at its own storage slot. So strings or arrays, things like that, they will not be shoved into previously existing slots. So this array will start at slot number 3. However, when we say it starts at slot number 3, the data type of this array's elements is a bytes 32. So what I actually mean is the first element of this array, this means, data 0, the first element of this array will go into slot number 3. It takes up all the 32 bytes. Notice I'm saying bytes now. So 32 bytes is 256 bits. Data 0 will be at slot number 3. Data 1 will be at slot number 4. And data 2 will be at slot number 5. This is the value we are interested in. We're interested in data 2 because that's where our key is held. So we need to be looking into slot number 5 to get its value out. What I'm going to do is, let's get a new instance first, and then we'll extract that value from this contract. Click confirm, and we'll wait for this to go through. Now that we have our own instance, let's extract slot number 5 from this contract. If you remember, web3.js comes with a helper function called web3.eth.getStorageAt, and we need to give it the contract address, so contract.address, and the storage slot number, which is 5 in this case. And this will give us this hex string, the whole bytes 32 string that is stored in data 2. Now, next thing to note, however, is the unlock function takes in a byte 16. It doesn't take in a bytes 32. It converts the value at data 2 into a byte 16. So when we do that conversion, because this is a smaller data type than bytes 32, and it's exactly half, it's essentially going to cut off this bytes 32 value and get rid of the 16 bytes at the end, right? So it's going to cut off and only keep the first 16 bytes. The 0x doesn't count, so the 0x isn't included. So what we're going to do is we're going to do the exact same thing. We'll do const b32 string equals this, right? And the length of this string right now is 66 characters, or rather it's 64 plus the 0x, right? So 64 characters plus the 0x, because every 2 characters in hexadecimal represents 1 byte. So what we need to do is we only care about the first 16 bytes, so the first 32 hexadecimal characters, and then if we include the 0x, we care about the first 34 characters from this string. So what we're going to do is we're going to do const b16 equals b32.slice. So we'll take a portion of that string. We'll do slice from 0 to 34. And you see it cut off halfway, and we now only have the requisite 16 bytes of data that the unlock function requires. So now it's as simple as just doing await contract.unlock, and we give it this byte 16 value, right? We give it this byte 16 value, and I forgot to add a parenthesis over there. And it will want to create a transaction. Click confirm and wait for this to go through. Awesome. Now that the transaction has gone through, let's take a look at this locked boolean. So we'll do await contract.locked, and you'll see it's now false. So now we're good to go ahead and submit this instance, and we'll go through, click confirm, and wait for it to be mined. Awesome. The transaction has been mined, and again, this just comes back to say nothing on the Ethereum blockchain is private. The keyword private is merely an artificial construct of the language, which goes back to the OOP days about private variables and how classes which inherit from other classes deal with such variables. It can be tricky to read what you want, because of compression or slot compression, as we saw, these 3 variables all got compressed into a single slot, and the order of these variables matters. So it can be tricky, but it's not impossible, as we were able to see. We were able to extract a single element from an array of data in this contract. So it doesn't get much more complicated than what we've already done in this level. And just use this as a reminder to never store any private information on the Ethereum blockchain, because there is no such thing as private data on a public blockchain. Cool. Hopefully you learned something. Hopefully you had fun. I will see you in the next one, which is going to be Gatekeeper 1.